All right. Here we go. Our objective for today is to derive and manipulate the area formula for a trapezoid. We're going to start out with a couple of definitions, and then we're going to move to an exploration activity. Okay? So these vocabulary words will probably be a review for most of you. Okay? Jaquan, what's the first vocabulary word on our list? Trapezoid. And Jaquan, how can we know that that's a trapezoid? What would we have to know about that quadrilateral? What makes it a trapezoid?
Two pairs of parallel sides.
Yeah, well, two sides that are parallel or one pair of parallel sides. So I would need to know that this side is parallel to that side. Put that marking in our trapezoid, and that's what we're going to put in for a trapezoid. A quadrilateral with one pair of parallel sides. I see Kira's getting it in her notes. Thank you, Brianna. Thank you, Jaquan. Quadre is getting his notes filled in. Okay. And another thing that we've talked about for some of our polygons is calculating the area. What does area mean? Yeah, go ahead. Good. Great.
Inside or around.
Right. Is it inside or around?
Inside.
Inside, absolutely. Do you remember what the distance around it is? Perimeter. Exactly right. Very nice. So the area is the space inside. I'm going to describe it a little bit more specifically like this. The number of square units it takes to cover the surface of a figure. Okay, to fit inside of that figure. Okay, so Bree, your definition was pretty close. Alright, we're going to talk about a long way of finding the area of a trapezoid. We're also going to talk about a shortcut. Okay, and that shortcut involves measuring the base and the height. Okay, so first of all, Quadre, in this picture, what do I mean by the base of the trapezoid? What do you think that I mean?
The top and the bottom.
You got it, the top and the bottom. Sometimes, like when we talk about triangles, we talk about one base, but in a trapezoid, we have more than one base. Okay, so this would be base 1, and this one would be base 2. There are two bases. Here's the definition that I'm going to have you put in. It says, the parallel sides which are often shown as the top and bottom. Alright. So we're going to be measuring the bases of our trapezoids, and then the last word is height. Kira, what is meant by the height of a trapezoid? What is your prediction here? The length of the shape, okay. And in what direction do you think that length would be measured? If we're talking about the height, would it go from side to side, or would it go from top to bottom? Top to bottom, okay. So if the bases are these parallel sides, which are often shown as the top and the bottom, then the height is the distance between those bases, okay. When I draw the height, I will draw it something like this. Okay? It goes like that. And one other thing that we need to note is that this distance is perpendicular to the base. You notice I put a little box here. Jaquan, what does that box mean? Perpendicular. How many degrees of an angle is that? 90 degrees. Absolutely. Okay? This will be labeled the height. Okay? So here goes our definition. It says the vertical distance connecting the top to the bottom, and this symbol means perpendicular. We know that the height is perpendicular to the base. Please take about 10 more seconds to complete those notes, and as you're doing so, I'm going to drop off our exploration for today. Today's exploration has 4 steps and then some reflection questions that I want you to take a look at. All right, Jake One, would you read the first gray section in our exploration for today? Good. How many square units fit inside the polygon? And there's a note there that says, count partial squares as a half. Okay? I want you to start this exploration independently. I'm going to come around and check on you. I'm going to give you exactly 5 minutes to complete all those parts and answer the conclusion questions at the bottom.
I have a question.
Okay. Question?
So, you want us to count all the boxes inside of this, right?
Correct. And then if there are any partial boxes, those count as a half. So if you have 2 half boxes, they would add up to 1 whole box. Good question. Any other questions before we begin? Alright, during this time there should be no talking, just silent work. I'll be coming around to check on you. It's 3:14. At 3:19, I'm going to collect feedback from you on the results. You can begin. Let's take a look. I'm just going to put this here. Alright. So, what do the instructions say for the first one?
How many square units fit inside the polygon? But I'm trying to find out what you're talking about, like square unit.
Okay. So, go inside the polygon. And what is it asking you to count?
Sixteen.
16. That would be the area. All right. Awesome job. Keep it up. Avery.
Wait, I have a question before.
Uh-huh.
Is this right? Because it's, I counted 9 squares, right? And then it was 7. It was 7 halves. So I
7. Some of them are really teeny. Count carefully your partial squares. Some of them are just a little sliver of a square.
So this
Uh-huh.
should be a partial.
Yeah, there's a right below that D. There's a little partial there. And count carefully the number of whole squares again. You might want to double check that.
For both of these. Both of these.
Particularly from what I heard you say about the trapezoid.
This.
The parallelogram looks perfect. Count the number of whole squares.
Okay.
All right, keep it up. Hey, Kira.
Hi.
You're doing great work.
Thank you.
Can I look at the trapezoid with you? All right. Can you count for me the whole squares inside the trapezoid?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16.
Cool. And that is the perfect number of units. You were just working on the parallelogram. Would you take a look at the trapezoid?
Okay.
Which one is the trapezoid?
This one.
Nice. How many whole squares are there?
It is 8 whole squares.
Good. So 8. And then we have to count how many half squares are there?
8.
There's 8 half squares. If each of those counts as a half,
Then that would be like 4 squares.
4. Okay, so you had 8 full squares and then 4 more from the half squares. How many would that add up to?
8 full squares. 12?
Yeah, you got it. Nice job. Keep it up. Hey, Quadre, how's it going?
That feels weird.
I'm sorry.
Okay, it's 8.
Mm-hmm.
1, 2, 3, 4, 5, 6, 7, 8, 9. And the point is good because it's half. That's kind of confusing.
Quadre, can I ask you about that trapezoid? How many half squares were there in the trapezoid?
8.
8. So if each of those counted as a half, how much would you have to add to that 8?
Another, the other half. So basically like be 8 and a half, then 9, 8 and a half, 9, 9 and a half, 10, 10 and a half, 11, 11 and a half, 12,
Good. So altogether, the area would be
12.
nice job. Keep it up. Please take about 30 more seconds to wrap up the last part of your measurements. No, that one's right. So there's 8 half squares. How much more is that? This one's 12. This one is not. How many whole squares?
Wait, you said it's 8. You said it's 8 half squares, right?
8 half squares. So if each of those counts.
It's 8. Plus 4 plus 4.
Take about 10 more seconds. I see a number of people working really hard to finish up. Continue working. I'm going to extend it for 10 more seconds. If you haven't measured the bases and the average of those bases, please do that now.
So we had to find a base. We had to find all 3.
Correct. Start with the parallelogram, the trapezoid, and the triangle. I am going to extend your time by just a little bit.
Wait, we got to do the bottom part?
Absolutely.
Go back.
For those of you that are looking at the base, you will see that I'm giving you a hint about which letters are the base, A, B, and C, D. You may notice that for the triangle, there's a star by C, D. If you're confused by that star, we'll go over that together. So it's the average. A divided by 2, right? We add 1, we divide by 11. What are the bases here? 4 is 1. What's the other base? 2. So 4 is 2. What's the average base? These look great. Awesome. Yeah, if you refer to your notes about what height means, it's the vertical distance from the base to the other base.
Yeah.
And you were right. Actually, what's the base here? There is no bases there. So the base here will be 0. Okay. Where's the top base? 2. What's the bottom base? 4. I noticed that you wrote 2 and 6. 2. How do we average these? And divide by 2. Okay. So it looks like you forgot to divide by 2. All right. Please, in 5 seconds, give me your attention up front. We are ready to go over these. Let's start with the areas. Jaquan, the area of the parallelogram. What did you get as the area?
Oh, my fault.
That's okay. 16, you got it. And I'm going to write 16 units squared. Alright, because our area is always described in squared units. Bree, talk to me about the trapezoid.
I had 12.
Good. You had 4 whole units. I'm sorry, 8 whole plus 4 more from the half. That gave you 12 units squared. Excellent. And Kira, how about the triangle?
I got 16.
16? How many whole units did you have?
I had 4.
4 whole units plus how many half units did you have? 8. What's half of 8? 4. Okay, so we have 4 plus 4 is 8, right? This 4 plus half of 8 is 8 units squared. Okay? Excellent. All right, let's talk about the bases now. Quadrate, what were the bases in the parallelogram?
Parallelogram. 8.
Okay. Can I ask you, what was the top base?
Oh,
4. What was the bottom base?
4.
4. And how do we find the average of two things? And then we divide by...
2, so it'll be 4.
You got it. 8 over 2 equals an average of 4. That was the average base. 4 units. Okay. Jaquan, how about in the trapezoid? What were my two bases?
4 and 2.
Good. 4 and 2. And when you averaged them, what did you get? 3, right? 6 divided by 2 was 3 units. Excellent. All right. And Bree, talk to me about the triangle.
I got AB was 4 and C was 0.
Good. The first base was 4 and the top was 0, right? And when I look at this triangle, there is no base at the top. All right? So it's like having a base of 0. When I average 4 and 0, what did I get? Good. 4 plus 0 is 4 divided by 2 is 2 units. Excellent. All right. Kira, let's take a look at the height now. What was the height of my first one? 4. Kira, I'm going to stick with you. What was the height of the second one? 4. And what was the height of the third one? Also 4. They all had a height of 4 units. All right, Quadrate, what does the fourth gray box tell us to do?
The product of the height and the average base.
All right, so the product means I'm doing what operation? Multiplication. So, Quadrate, what is the product for the parallelogram of the average base and the height? Yep.
4 times 3, 4 times 2.
Well, let's do the first one. What's 4 times 4?
16.
16. Jaquan, what was the product for the trapezoid? 12. And what was the product for the triangle? 8. Each time we're multiplying the average base by the height, the average base by the height. Alright? Bree, can you read the question that is posed right below our data here?
What do you notice about the area of each polygon and the product of the height and the average base?
Okay, so let's take a look at that. At the top row, I see the area, 16. And what did you notice about the product of the height and the base? It was the same. What about for the trapezoid?
Same.
Same. How about for the triangle?
Same.
It was the same. So, our answer here was, they are the same. Now, Kira, what does the last question ask us to do?
Create a formula for calculating the area of a trapezoid.
All right, so the area of a trapezoid is the product of what two things?
Triangle and...
Raise your hand. Kira, go ahead. The area of a trapezoid was the product of what?
Is a product of
The height
times
times
base
the average.
average.
The average base. And how did we find the average of two bases?
I the 2 bases and divide it by 2.
Add the 2 bases and divide by 2. So base 1 plus base 2 over 2. Put a box around this formula. You guys just derived the formula for the area of a trapezoid. Very nice job. Hey, your focus so far has been great. We're going to go very shortly back to your notes for a quick example, and then we'll go to independent practice. Save the independent practice for a little bit later. Right now, go back to your notes. I see Bree is already back on her loose leaf paper. Quadre is about to switch back to his. Kira's already back on hers, and Jaquan is also back on his. Okay? What I want to do is build connections with you between some of our area formulas. Some area formulas we already have talked about, and some of them are new. Okay? So let's start with trapezoid. Quadre, what was the formula for a trapezoid?
A equals B1 plus B2 over 2.
Over 2 times the height. Exactly right. Alright, now what about for a parallelogram?
You have to do the picture.
If you want to just write trapezoid, you can do that. Okay? And of course, in a trapezoid we have B1 and B2, and we have a height. Now, in a parallelogram, what do we know about the opposite bases? They are certainly parallel. What do we know about their lengths? This is, you got it, they're the same. This is from another exploration that we did. If this one is B1, then what do we know about the length of this? It's also going to be B1. You recall it B1 and B2 because they're different. In a parallelogram, you may recall that the bases are the same. So, if I'm doing A equals B1 plus B1 over 2 times H, another way of writing B1 plus B1 is 2 times B1 over 2 times H. Jaquan, what can I cancel right now?
2.
The 2's. So, if I wanted to write the shortened form, what does that simplify to?
B1 times height.
The base, B1 times height. The area equals the base times the height. Does that formula look familiar to you?
Yes.
Yeah, this is one that we've worked with before, okay? It's related to the other formula, but it can be simplified, okay? Same thing for a triangle. Here I have a base, and what did we say about the top base? It's nothing, it's 0, okay? So if I use the same setup, B1 plus 0 over 2 times H.
But I have a question.
Go ahead.
Why is it not A equals 1 at a time, B times height?
A equals 1/2 times base times height. Is that the same thing as this? Multiplying by 1/2 is the same thing as dividing by 2. Okay? So in fact, go ahead.
You just took the 1 off the top. But
Yeah.
you're canceling it out.
Well, when I say B1, I'm noting that if I have 2 B's, it just tells us the difference. You're right that I actually don't need that B1 to be there because it's the only base in my picture. The other base is a 0. Okay? But basically, we see that that 0 doesn't need to be there, and we see that that's the formula that we're used to seeing. All right? In your independent practice, you're going to see all 3 of these formulas in problems like this. All right? Make a quick sketch of the picture. You don't need to have a perfect picture, but make a quick sketch of it. And this is the word problem. It's the only word problem I'll ask you to write, and the rest will be on your independent practice. It says, solve for x, given that the area of the trapezoid below is 48 centimeters squared. Solve for x.
Yeah.
solve for x given that the area of the trapezoid below is 48 centimeters squared. All right, someone give me a raised hand. What formula will I start with? Give me a raised hand if you think you know which formula I can start with. Give me a raised hand if you think you know. Kira. You got it. I'm going to start with the trapezoid formula, which is? Times height. Perfect. All right. What is some of the information that I can plug in? Jaquan, can you get us started here?
You can plug in 48
What is that? That's the area. Okay, so he sees that right in the setup. They're giving us the area, 48 centimeters squared.
plus x plus 10.
X plus 10 are going to be our two bases, B1 and B2. Divided by 2.
Times 4.
And we know that the height is 4. Exactly right. Now, Quadre, can you step in here? What would you do right now to simplify this equation?
Keep 48 as it is. I think you put 2x plus 5 times 4.
What?
Okay, wait a second. Quadre, what you're doing right now is you're dividing the 2 by both of these terms, right? So you wanted to divide the 10 by 2?
Okay, I can do it. 48 equals x plus 5 times 4.
Why just divide the whole thing?
Here's the problem, Quadre, is that if you divide this by 2, that's great. I like the plus 5, but there's still, this 2 is also being divided by this x. Okay? So we can do something with this 2. We can split it up, but the way you said it was not quite correct. Can somebody help them out? Give me a raised hand if you think you can step in. Great. You want to multiply both sides by 2? I kind of like that way of doing it as well. Quadre, if I multiply this side by 2,
Divide?
what happens?
Huh?
Times 8.
If I multiply this side by 2, what happens to my 2?
Crosses out.
It crosses out. Okay, if I do it to this side, I have to do it to
That side.
that side. Times 2. Okay?
Can we
Good.
divide?
Yeah, we are going to divide in just a second. Alright, what do I get here?
Like
96.
96 equals, what is left?
X plus 10
X plus 10
times 8.
times
4.
Oh, 4.
4. The 2 canceled. Alright, now, can I get rid of that 4?
Subtract.
Am I adding the 4?
I'm not.
Oh, you multiply the 4 to both sides. Like to the actual 10.
What operation, Quadre?
Okay, how you division? Huh?
Give me a raised hand. What operation do I need to do, Quadre, to cancel this 4?
600 by both sides.
Good.
I just can't remember the name.
Quadre, let me ask you this. What operation am I doing right now with that 4?
Multiply.
And then how do I cancel something?
Divide it.
I have to divide. You got it. It's the inverse operation. So if I divide this by 4, the 4 is canceled. I'm going to rewrite my equation here. What is 96 divided by 4?
24.
24 equals x plus 10.
And you subtract 10 on both sides, you get 14.
Now I can subtract. Minus 10 minus 10. And I get x equals 14. We good? Alright. I will be coming around to check on your work. On the back of your exploration, you will see 6 problems that you need to have finished by the end of class. Alright? Right now, it is 3:38, which means that you have about 13 minutes to finish those 6 problems. I'll come around and check on you. You can begin.
You said what?